on your YouTube?
Are you a subscriber now?
I have.
We just got through example 4.
Yeah.
Yeah. That's all we did. That makes me so happy. Oh, I just started recording it now. I wonder if this one's on my YouTube channel, too. I just didn't bother looking. Plus, you never know. Like, maybe we talk about different things. Okay. So, let's see here. How does logarithmic differentiation work? You might be asking yourself. Okay. So basically, the first thing I want you to notice is that there is no log in the expression. Do you guys see that? Okay. So logarithmic differentiation is the process of taking the log of something to make the exponential thing come down. Can I go for memory on this?
Been 2 years. You might not be surprised.
What?
Oh, I am. Tried some angle this week, yeah.
Okay. So the process of introducing logarithms before differentiating. And also typically there's not a number that's in a base, but it's an x in the base. So you kind of see an x and then you see a function. It's not exponential because if we're exponential, we could use the exponential rule. Do you see how this is not an exponential function? Okay, and it's not a power rule because that would be like x to the 5th and we could bring the power down. So what we do though, because I can't really use any of the rules that I know so far, is I use the property of a log that brings an exponent down. So I'm going to take the natural log of both sides first. What's going to happen to this cosine of x? It's going to come down. So I have natural log of y equals cosine of x times natural log of x. At this point, we use implicit differentiation. What's that? That's where I take the derivative of both sides. And if there's something with a y, I have to write dy dx after it. So, I'm going to ask this question again. What's the derivative of natural log of y? 1 over y dy dx. That's what this side's going to be. On this side, we are going to do product rule. So let's do first d second. Cosine x times, what's the natural log of x? What's the derivative? 1 over x plus second d first would be natural log of x, and what's the derivative of cosine? Cosine. All right, now remember I'm trying to figure out what dy dx is, so how could I get dy dx alone? Couldn't you just multiply both sides by y?
Oh, yeah.
Oh, so I'm going to do that. So I have dy dx, and our last step is that we, in place of y, we go up to above and we put the y back in. Do you remember how y was x, cosine the x? So I'm going to just take out this right here. See that y that I just circled? And I'm going to put the original value in for that, and then I am done. So I'm going to just leave it in parentheses. This would be cosine of x over x. This would be minus sine of x times natural log of x. And then times y, I'm going to just write times x to the cosine of x. So just so you've seen that before. So it does not involve, well, it involves taking the derivative of a natural log, but because you put it in. Because you have to put it in it. So it's only when there's an x to some other function that we would use that. And that is not an AB topic. It's not on the AP exam. It is in our textbook in this lesson, and it is a BC or Calc 2 topic. So you will see that at some point if you continue on. Yes.
Problem on our AP review for us that you wanted to talk about?
What?
There's a problem on our AP review that you told us that you wanted to talk about.
Okay. Remind me in 5 minutes. Okay. All right. The other thing I wanted to talk about is logistic functions about rates of change. And a logistic function, there's no special rule to memorize. It just is that it's a function that has an exponential function in it. Okay. So, you've hopefully seen before that logistic functions often model population, right? So if I would want to find how fast this flu is spreading in 3 days, if this is the spread of the flu modeled by this equation, where P is the total number of students infected, that involves a rate of change, correct? So that's going to involve taking the derivative. Okay, let's just first review. This you can use a calculator for. If this represents the population of the flu, do you guys remember what the 100 stands for? It's the maximum carrying capacity. That's the maximum number of students who would ever get it. Okay. The question was estimate the initial number of students affected. That's just P of 0. So if we plugged in 0, it would be 100 over 1 plus e to the third. Let's figure out what that is. Did you? Good job. Okay, so if I'm talking about like rounding as far as calculus goes, we'd say 4.742, but these are people, so what should we round to? 4, I would say, can we round up to 5? It's closer to 5. You want to call it 4? You can call it 4. I would accept either. B, how fast? So what I'm looking for here is that, like on your test, for instance, if I ask a question, that you understand how fast something is spreading as a rate of change. So I'm first of all looking that you understand this is the derivative at 3 days. Okay. Second of all, just understanding that is great because then I know that you're getting the concept. Okay. Then can you use some of our calculus rules to actually find the derivative and plug in the value? So let's go ahead and write our function out. What I'm going to do this problem is I want to avoid quotient rule. And so I'm going to write this as 100 times 1 plus e to the 3 minus t to the negative 1 power. Are you all on board with that? Okay. This is not even product rule. This isn't a function, is it? No. So we don't even have to do product rule. This is just a chain. It is a chain. We're going to have to do the negative 1 and bring it down and then multiply by the derivative of what's inside, but we're not going to have to do product rule or quotient rule. All right, are you ready? So now we're going to do P prime of t. The negative 1 comes down to the front. That becomes negative 100. We do not change what's on the inside. So 1 plus e to the 3 minus t. And now what's the exponent of that? Negative 2. Good. And the last thing is I'm going to multiply by the derivative of what's inside. Now the derivative of 1 is nothing, right? The derivative of e to the u is e to the u du. Can somebody tell me what that is? It would be e to the 3 minus t, but do you see how it's a negative t? So I would have to put a -1 there. Okay, as far as plugging in points, if you have the use of your calculator, you can at this point plug in points. At this point, plug in points. 2 points. Let's talk about if I were to write this as a function where the things would go. If it's a negative exponent, where do I put it on the fraction? On the bottom. So -100 would go on top. This would go on the bottom. Wouldn't this also go on top? If I had a negative and a negative, see these two negatives here? Are you okay with me just changing that to a positive? Okay, so let's plug in 3. Let's get our calcs out, guys. Now, I hope you're noticing when you plug in 3 here, actually, it's just 3 minus 3, that's e to the 0, and e to the 0 is 1, so I think the top is going to be 100, right? Okay. And then on the bottom, I have 1 plus e to the 0, which that would be 2 squared. Are you following? 1 plus 1 is 2, and 2 squared is 4. Do you want me to explain that again? What I was doing? Or you got that? Okay. I'm missing a unit. What do you think my unit is? It's a rate. So right at that day 3 day, the people getting the flu, it's increasing by 25 students per day at that time. So 25 more students a day. Now, it's only true just for that day because it's changing. It's an ever-changing rate. But on that day, that is how fast it's growing. 25 more kids a day are getting it. Okay. What if I asked you to find the maximum rate? This is where I'd have to have you use a calculator at this point because that's asking you to graph the derivative and find its maximum. And so what we're going to do is we're going to graph it. I'm going to show you something, but we're going to do that graphically. So we're going to graph P prime and take a look. So we're going to just use X. Hey, make sure when you're doing division that you put this in parentheses. Let's see what we got here. I did select Zoom 6 and that's what I see. We can't see the max, correct?
Right.
So let's go up higher. I don't know, what do you want to try?
30.
So I'm going to change Y max to 30. Hit graph. Okay. And then, are you following what I'm doing? We're finding the max. So I do max. I make sure I'm to the left. I hit enter. And go into the right. And I hit enter. And I'm going to guess. And, oh, weird. It's 25. Isn't that what we found in the first one? 25 students per day, and then it would be at day 3. So I have a question for you guys. When do you think in this kind of situation in a logistic function that it always grows at its fastest rate? Do you know something special about when I plugged in 3?
When exponent is 0.
So always, just interesting. You can graph it and always find it, but it is always going to be whatever makes the exponent 0 when it will grow at its fastest rate. So. Okay.